Hello guys, Assalamu alaikum, Bismillahir Rahmanir Rahim. Today with another topic, multiplication of matrices. Two matrices A and B are conformable for multiplication if the number of columns of A is equals to number of rows of B. For example, A matrix has 1, 2, 3, 4, 5, 6, 3 rows and 2 columns. What is the order of this matrix? 3 rows and 2 columns. And there is another matrix B whose order is 5, 6, 7, 8, 9, 10 for example, and its order is 2 into 3. Now check, the number of columns of A is 2 and number of rows of B also 2. So these two matrices are conformable for multiplication. You can see order of A is 3 into 2 and order of B is 2 into 3. So this is same. So we can say the number of columns of A is equals to number of rows of B. And after multiplication, after the product of AB, the resultant matrix must have this order 3 into 3. If this condition will not satisfy, then multiplication of matrices is not possible. Let's see another example. For example, C is having elements 1, 2, 3. Its order is 3 into 1. And there is a matrix B 5, 6, 2, 0. Its order is 2 into 2. So is it CB is possible? 3 into 1 and 2 into 2. This is different. So not possible. Number of columns of C is not equals to number of rows of B. Even BC is also not possible. BC is also not possible. So first you need to write the order of B and then the order of C. This also not possible. Here is BA is possible. AB is already possible. Multiplication. The product BA is possible or not. So first write the order of B 2 into 3 and then write the order of A, which is 3 into 2. Yes, this one is also possible. BA is also possible. And the order of the resultant matrix will be 2 into 2. Means after multiplication, the order of the answer will be 2 into 2. Now the question is how to multiply two matrices. So let's say there is a matrix A whose elements are 1, 2, 3, 4, 5, 6, 0, 1, 3 for example. And there is another matrix B whose elements are 0, 2, 1, 3, 5, 1, 6, 7, 8 for example. Now we need to find AB. So first check the order of A. A is 3 into 3. The order of B is 3 into 3. So write the order of A first, then the order of B. This is same. It means multiplication is possible. So how to find AB? You can write first A and then B. 1, 2, 3, 4, 5, 6, 0, 1 and 3. Now write B multiplying. There is no sign. It's mean it's multiplication. 0, 2, 1, 3, 5, 1, 6, 7 and 8. Now this row will multiply with this column. So how? 1 will multiply with 0, plus sign, 2 will multiply with 3, plus sign, and 3 will multiply with 6. So 1 with 0, 2 with 3, and 3 with 6, like this. Similarly, first row will multiply with second column also. So 1 with 2, 1 with 2, plus 2 into 5, plus 3 into 7. Similarly, first row will multiply with last column also, third column also, and we will write here 1 with multiply with 1, plus 2 with 1, plus 3 will multiply with 8. Similarly, second row will multiply all three columns. So how it will multiply? 4, 5, 6. Only row will change, column will be same. So you can write here 4 into 0 plus 5 into 3 plus 6 into 6. Again 4 into 2 plus 5 into 5 plus 6 into 7. Again 4 into 1 plus 5 into 1 and 6 into 8. Next it will be this one. You can see the column I am writing same as it is this one. 2, 2, 5, 5, 7, 7, 1, 1, 1, 1 and 8 and 8. Last one, row 0 and 1 and 3. Just change the row, column will be same, 0, 1 and 3, 0, 1 and 3, and here same, column matrix will be same, column will be same, this column, second column 2, 5, 7, plus sign, and 1 here, plus 1 here and 8 here, plus sign. Space is less, that's why I am writing like this. Equals to 1 times 0 is 0, 2 times 3 is 6. So we can write 0 plus 6 plus 6 times 3 is 18. 2 plus 10 plus 21. 1 plus 2 plus 2 times 3 is 54. Similarly, 4 times 0 is 0, 5 times 3 is 15, 6 times 6 is 36, 4 times 2 is 8 plus 25 plus 42, 4 plus 5 plus 48, 8 times 6 is 48. So 0 plus 3 plus 18, 0 plus 5 plus 21, and 0 plus 1 plus 24. So finally we will get 24, 18 plus 6, 30, 31, 33, and 55, 56, 57, and 42, and 75, again 57 here, 18 plus 3 is 21, so 26 and 25. Now you can see the order of this one is 3 into 3. So this is how you will multiply two matrices. Next is commutative law of multiplication of matrices. So in general, AB is not equals to BA. If two matrices A and B are conformable for multiplication, but in general AB is not equals to BA. In some particular cases, you can say AB is equals to BA. Remember that commutative property doesn't hold for multiplication of matrices. Now, associative law of multiplication of matrices says that if there are three matrices A, B and C and they are conformable for multiplication, all three should be conformable for multiplication, then we can say that AB into C is equals to A into BC. So this is called associative law of multiplication of matrices. We will prove this one with the help of example in exercise. If there are two matrices A and B and both are conformable for multiplication, then B will be the multiplicative identity of A. If you multiply B with A and you will get same A. Identity matrix is the multiplicative identity of matrix. Why? Because if there is any matrix A and there is an identity matrix and both are conformable for multiplication, then AI or IA will give you the same matrix A. So that's why identity matrix is called the multiplicative identity of a matrix. For example, we have A is equals to 1, 2, 3, 0, minus 1, 5, 7, 8 and 9. Now if you multiply this one with I, you have to take I of the same order. A is 3 into 3, so I also take 1, 0, 0, 0, 1, 0, 0, 0, 1, 3 into 3. So AI will be this row, you will multiply with this column, 1 into 1 plus 2 into 0 plus 3 into 0. Similarly, the same row you will multiply with second column and third column. So you will get 1 into 0 plus 2 into 1 plus 3 into 0. Same 1 into 0 plus 2 into 0 plus 3 into 1. Three into 1. So here again 0 minus 1, 1 plus 0 plus 5. Second row will multiply with first column. So 0 minus 1 and 5. Here it is plus 1 plus 0. So 0 into 0 plus minus 1 into 0 plus 5 into 1. Similarly 7, 8, 9, 7, 8, 9, 0, 0 and 1, 7 into 0 plus 8 into 1 and 9 into 0. So 7 into 0 plus 8 into 0 plus 9 into 1. So what we will get, 1 plus 0 plus 0, 1 plus 2 plus 0, 1 plus 0 plus 3, 0 minus 1 plus 0, 0 minus 0 plus 0, 0 minus 1 plus 0, 0 plus 0 plus 5, and similarly here 7 plus 0 plus 0, and 7 plus 8 plus 0, and 0 plus 0 plus, here also we have 0, 7 times 0 is 0, and 7 times 1 is 7, sorry 9, 9 times 1 is 9. So what we will have, 1, 2 plus 1 3, here also 0 times 1 is 0, so here also 0 plus times 1 is 0, so we will get 2 here, here 3, here 0, minus 1 and 5, similarly 7, 8 and 9. What is this? This is A. So identity matrix will be the multiplicative identity of a matrix, of any matrix. And here you know that identity matrix is always a square matrix. So either it will be of order 2 into 2 or 3 into 3 or even 1 into 1. Next is distributive law of multiplication of matrices under addition. It's mean if there are three matrices A, B and C, and all three are conformable for multiplication, then A into B plus C will be equals to AB plus AC. This is called left distributive, because we are multiplying from left side. Now what will be right distributive? Here you can write A plus B and multiplying C, so AC plus BC, AC plus BC. So this is called a right distributive because we are multiplying from right side. C is multiplying, C is on the right side, so this is right distributive. Similarly we have this law for subtraction also. So A, B and C are three matrices and conformable for multiplication, then A into B minus C is equals to AB minus AC, AB minus AC. This is again left distributive over subtraction. So right distributive will be, you can say A minus B into C, so AC minus BC, AC minus BC. This is right distributive. There is another property of transpose. If you take the transpose of AB, then this will be equals to B transpose into A transpose. And this property we will prove in exercise with the help of question. You cannot say that AB transpose is equals to A transpose into B transpose. This one is wrong, this one is right. So AB transpose will be equals to B transpose into A transpose. Exercise 1.4, question number 1. Which of the following product of matrices is conformable for multiplication? You need to find the order of matrices first. So what is the order of this one? 2 rows and 2 columns, 2 into 2. Write this order here. This is first matrix, and the second matrix has order 2 rows and 1 column, 2 into 1. Write this one here, 2 into 1. So here you can see number of columns of the first matrix is equals to number of rows of, this is the condition, and after multiplication you know that the product will have this order. This will be the order of the product AB, order of AB, but this is the condition this side. So 2 is equals to 2, number of columns is equals to number of rows of the second matrix. So the first part is confirmable for multiplication. Look at second part. Order A of first matrix is 2 into 2 and the order of second matrix is 2 into 2. Write here first matrix, the order of first matrix and the order of second matrix, and check this one. This is same, so it means this one is also confirmable for multiplication. The product is possible. Part 3, order is 2 rows 1 column of the first matrix. Write here 2 into 1, and the second matrix has order 2 rows and 2 columns. Right here. Now check, the number of columns of the first matrix is not equal to the number of rows. First matrix has 1 column and the second matrix has 2 rows, which is not same. So here in part 3, product will not be possible. Product of these matrices will not be possible. So we can say these two are in part 3, two matrices are not confirmable for multiplication. Part 4, check, the order is 3 rows and 2 columns, and second matrix has 2 rows and 3 columns. Now you can write here 3 into 2 and 2 into 3. Check this one, 2 and 2. So number of columns is equal to number of rows of the second matrix. So here also product is possible. Now number 5, the order is 2 rows 3 columns, 2 into 3. First you need to write this one, first matrix first. The order of first matrix must be first, and then the order of second matrix, 3 into 2. Then check this one, this is same, 3 equals to 3, yes. So these matrices are confirmable for multiplication. Number 5. So only part 3 is not possible, remaining all are possible. How to multiply we will see in the next questions. Here we are just checking the condition. Is it possible, multiplication is possible or not. Question number 2 says, if A is 3 0 minus 1 2 and B is 6 5, find AB and BA. The product of A into B and the product BA if possible. So what is the order of A? The order of A is 2 into 2 and the order of B is 2 rows and 1 column, 2 into 1. So for AB, part 1 solution, check 2 into 2, 2 into 1. So number of columns of A is equals to number of rows of B. Number of columns of A is equals to number of rows of B is equal. So AB is possible. Multiplication of A with B is possible. Now we will see how to multiply. This will be the order of the product of the answer. So now we will find AB. First write matrix A, 3 0 minus 1 2, and then multiply with B. Write the matrix B, 6 and 5. Now how you will multiply? This row will multiply with this column, first column. So we will write here 3 times 6 plus sign between them, 0 into 5. First row is multiplying with first column, so you wrote in the first row and first column. Now second row will multiply with this column again. So how you will multiply? Minus 1 will multiply with 6 plus 2 will multiply with 5. So I will show you how you will multiply 3 with 6 and 0 with 5. Similarly, minus 1 first with 6 and 2 with 5 then. So we will get 6 times 3 is 18. 5 times 0 is 0. 6 times minus 1 is minus 6 plus 5 times 2 is 10. So which will be 18 plus 0 is 18 and minus 6 plus 10 is positive 4. What is the order of this product? 2 rows and 1 column. Here we have seen 2 rows and 1 column. So this is our answer. This is our AB. Now for BA, we can check again. Now you need to write first this one for BA. 2 into 1 and then 2 into 2. Now you can see number of columns of B is not same as number of rows of A. So BA is not possible. Okay. In question number 3, find the following products. We need to find the products of two matrices. So first one we will see what is the order of first matrix, 1 row and 2 column, 1 into 2, and the order of second matrix is 2 rows and 1 column. So solution of part 1, 1 into 2 and 2 into 1. So these are same. The number of columns of first matrix is equals to number of rows of the second matrix. So multiplication is possible, and the answer of the resultant matrix of the product A will be 1 row and 1 column. At the end we will get. So let's multiply 1 2 is multiplying with 4 and 0. So first one will multiply with 4. 1 into 4 plus 2 will multiply with 0. 2 into 0. We have one row. This row will multiply with this column. That's it. There is only one row. So 4 plus 1 5 plus 2 times 0. 2 times 0 is 0. So 5 plus 0 will be 5. So the order of this matrix is 1 into 1, as we know already. So this is the answer, part 2. Same, 1 into 2 and 2 into 1, so multiplication is possible. So how we will multiply? This row will multiply with this column, 1 with 5 and 2 with minus 4. 1 with 5 plus 2 will be multiplied with minus 4. So 5 minus 8 is equals to minus 3, and it has one row and one column. So this is the answer for 2. Now part 3 is also same. 1 into 2, 2 into 1, 1 into 2 and 2 into 1. Multiplication is possible, and the order of the resultant matrix will be 1 into 1. So 3, I am multiplying this row will multiply with this column. First element will multiply with first element and second with second. First element of the row will multiply first element of the column, and second element of the first row will be multiplied with the second element of the first column. So minus 3 into 4 plus 0 into 0. This is the process of multiplication. Minus 12 plus 0, which will be minus 12 matrix. Order is 1 into 1. So this is your answer. Now next two questions, 4 and 5. 4 again same, order is 1 into 2 and 2 into 1, 2 rows and 1 column. So 6 will multiply with 4. I don't know why they have written minus 0. Anyhow, 0 will multiply with 0. Number 4, 6 into 4 plus 0 into 0. 6 times 4, 10. 10 plus 0 will be 10. And the order is 1 into 1. To check. Fifth one, order 3 rows, 2 columns, 3 into 2, and the order is 2 into 2. Of the second matrix, order is 2 into 2, 2 rows and 2 columns. Let's check. 3 into 2, 2 into 2. So number of columns equals to number of rows of the second matrix. Its mean product is possible, and the answer must be this one. The order of the answer must be this one. Now how you will multiply? First row will multiply with first column. 1 will multiply with 4. Plus 2 will multiply with 0. Still we are in the first row. Again first row will multiply with second column. So 1 will multiply with 5. Plus 2 will multiply with negative 4. Now second row, let me change the color. Second row will multiply with first column. So minus 3 will multiply with 4, plus 0 will multiply with 0. Similarly, second row will multiply with second column also. How? Minus 3 will multiply with 5. First element with the first one and second element with the second one. And plus sign between them. 0 will multiply with minus 4. Similarly, third row will multiply with first column. So 6 will multiply with 4, plus minus 1 will multiply with 0. And then again third row will multiply with second column also. 6 will multiply with 5, plus minus 1 will multiply with minus 4. You can see the order of this one, 3 into 2. We need this order. And one more thing you can check here, this will be same, 4, 4, 4, 4. Here this 0 will be same. Only row elements are changing. So here this 5 will be same. And minus 4 is also same here. Anyways, 4 times 1 is 4, plus 2 times 0 is 0. 5 times 1 is 5, minus 4 times 2 is 8. Negative 12 plus 0. 5 times 3 is minus 15, plus 0. And 6 times 4 is 24, minus 0 or plus 0. 30 minus minus plus 4. 4 times 1 is 4. So this will be equals to 4 plus 0 is 4. 5 minus 8 is minus 3. Minus 12 minus 15. 24 and 34. This is our required matrix, product AB, and the order of this one is 3 into 2, 3 rows and 2 columns. So this is your answer. Question number 4, multiplying the following matrices. So solution for part A. First of all, write the order of first matrix, which is 3 rows and 2 columns, 3 into 2, and second matrix has order 2 into 2. So 3 into 2 write first, 2 into 2 write second. So this is same, it's mean the product is possible, and after multiplication we must have this order 3 into 2, means we must have 3 rows and 2 columns in the product. So we are going to multiply. First let me write so that it will be easy. 2 into 3, 1 into 1, 0 minus 2. This matrix is multiplying with 2 minus 1, 3 and 0. So how we are going to multiply? First of all, this row will multiply with this column, and again this same row will multiply with the second column. So we need 3 rows and 2 columns. 3 rows and 2 columns. So how you are going to multiply? 2 will multiply with 2 and 3 with 3. So 2 times 2 plus sign and 3 with 3. Similarly, first row with the second column, 2 is going to multiply with minus 1 and 3 will multiply with 0. 2 with negative 1. You will give some space because this is second column now. 3 will multiply with 0. Similarly, now second row is going to multiply with first column and second column. So only row will change, column will not change. So row is 1, column is 2, plus 1, 1 and column is 3. You can see from here and write the same element. Row is 1, minus 1. Here we must have plus sign, I forgot. And here second element is 1 and column is 0. Likewise, this third row is going to multiply with the same column, first column and second column. So column elements will not change, only row will change. So 0 here, minus 2 here, 0 here and minus 2 here. Column elements you can write as it is, 2 plus this 3 here, this minus 1 here, plus and this 0 here. So we have 3 rows and 2 columns. So which will be equals to 2 times 2, 4, 4 plus 3 times 3, 9. Negative 2 plus 0, 3 times 0 is 0. 2 plus 3 times 1 is 3. 1 times 1 minus 1 is minus 1. 1 times 0 is 0. 0 and minus 6. 0 minus 6. 0 and 0 when you multiply 0 plus 0. So finally you will get 13 minus 2, 5, minus 1, minus 6 and 0. What is the order of this matrix? The order of this product is 3 rows and 2 columns, which is required. So this is your answer. Next question for part B. Same, first you need to find the order of this one. I will do it here. Order is 2 rows and 3 columns, and here we have 3 rows and 2 columns. So you can see the number of columns of the first matrix is equals to the number of rows of the second matrix. So multiplication is possible. Now how to multiply? This row will multiply with this column. 1 will multiply with 1, plus 2 will multiply with 3, plus 3 is going to multiply with minus 1. Like this, first row will multiply with second column also, 1 with 2 plus 2 with 4 and plus 3 with 1. 2 into 3 order of first matrix and 3 into 2 is the order of second matrix. This one is same, so multiplication is possible and we need 2 rows and 2 columns in multiplication process. Now second row will multiply with first column and with second column. So only rows elements will change. So rows element 4, 5 and 6. Here also 4, 5 and 6. And column elements you just copy same as it is, 1, 3 and -1. This is the shortcut, 4 plus 1. This one same. So now 1 times 1 is 1 plus 3 times 2 is 6. 3 times -1 is -3. Similarly 2 plus 8 plus 3. 4 plus 15 minus 6. 8 plus 20 plus 6. So 6 plus 1 7, 7 minus 3 is 4. 8 plus 3 is 13. 8 plus 2 10, 10 plus 3 is 13. Minus 2 plus 15 will be 13 here again. 15 plus 4 is 19. 19 minus 6 is 13. So here we will get 28, 34. So this will be your answer. You can see the order of the product is 2 into 2. 2 rows and 2 columns, which is required. Part C is also same. We have order of the first matrix, 3 rows and 2 columns, 3 into 2, and here we have 2 rows and 3 columns, 2 into 3. So multiplication is possible and we need this order of the product, 3 into 3. So this row is going to multiply with first column, second column and third column. So first of all 1 will multiply with 1 plus 2 is going to multiply with 4. Now 1 with 2 and 2 with 5. Again 1 with 3 and 2 with 6. Next 3, 4 row will change only, just write rows elements 3, 4, 3, 4, 3 and 4, -1 and 1, -1 and 1, -1 and 1, -1 and 1. Copy the columns element, 1 here plus 4 here, 1 here plus 4 here, 2 here plus 5 same, 2 plus 5 same, here 3 plus 6 same, 3 plus 6 same. So which is ordered 3 by 3. Now 1 plus 8, just multiply 3 plus 12, 3 plus 16, 3 times 2 6 plus 20, 9 plus 24, -1 plus 4, -2 plus 5 and -3 plus 6. Just simplifying addition and subtraction. So 8 plus 1 9, 10 plus 2 is 12, 12 plus 3 is 15, 16 plus 3 is 19, 26, 24 plus 9 is 33, and 4 minus 1 is 3, 5 minus 2 is 3, 6 minus 3 is 3. So order of this product is 3 into 3. Hope answer the question. Next is part B. So order is 2 into 2, 2 into 2, 2 into 2, 2 times 2. Multiplication is possible, and the product will also have the order 2 into 2. So this row will multiply with this column. The same row will multiply with the second column also. So A times 2, first element with first element plus sign, second element with the second element. Again 8 times minus 5 by 2 plus 5 times 4. Again 6 and 4, 6 and 4, rows elements same, 6 and 4, and column elements you can copy from above, minus 5 by 2 plus 4. Just I am copying this one. Now what you will get, 8 times 2 is 16, minus 5 times 4 is 20, minus 20. 2 times 4 is 8, 5 times 4 is 20, which will be minus 20. 5 times 4 is 20, 6 times 2 is 12, minus 4 times 4 is 16. 2 times 3 is 6, negative 15 plus 16. So we will have negative 4, 16 minus 20 is minus 4, minus 20 plus 20 is 0, negative 4 and 1. The order is 2 by 2. Next part E. E is equals to, this row will multiply with this column, minus 1 into 0 plus 2 times 0. Again this row will multiply with this column, minus 1 into 0 plus 2 into 0. Remember, the order of first matrix is 2 into 2 and the second matrix is also 2 into 2. So multiplication is possible, and we must maintain this order for multiplication. So second row will multiply with first column and second column. Elements are 1 and 3. Right here 1, 3, 1 and 3. Column elements just copy from above. Now, so what we are going to get, 0 plus 0, 0 plus 0, 0 plus 0, 0 plus 0, which will be 0, 0, 0, 0. You can say null matrix, and the order is 2 into 2. So this is the answer. So this is the answer. Now question number 5, A is given of order 2 into 2, B is of order 2 into 2, and C is also of order 2 into 2. Multiplication is possible, AB, BA, AC, BC, CA, all are possible. So just we need to verify that whether AB is equals to BA. Is it commutative with respect to multiplication, or is it associative or distributive? Laws over addition and subtraction verifies or not, we have to check all this. Solution for first one, let's find AB first. So what will be AB? First write the element of matrix A and then multiply with B. 1, 2, minus 3 and minus 5. Matrix B. When there is no sign, it's multiplication. So minus 1 will multiply with 1. First row will multiply with first column. Minus 1 with 1. And plus sign, and 3 with minus 3. Likewise, minus 1 will multiply with, now first row we are multiplying with second column, so minus 1 with 2 plus 3 into minus 5. Same second row with first column. Second row has elements 2 and 0. So write here 2 and 0. And this one you can copy from here, minus 3 from here, 2 and minus 5. This I am copying. Column elements will be same, only row will change. So that's why we can copy like this. In exam, no need to put these arrows, okay? This is only for your understanding. So negative 1, minus 9, minus 2, minus 15. 5 times 3 is 15, plus minus minus. 2 plus or minus 3 times 0 is 0 anyhow. 2 times 2 is 4, minus 5 times 0 is 0, plus 0 minus 0 doesn't matter. Now we will have minus 10, minus 17, 2 and 4. This is the answer for AB. Now we need to find BA, and we need to check whether it is this relation established or not. This is possible or not. This is AB is equals to B or not. Whether means it may or may not be possible. Now let's find BA. So BA is equals to, first write the elements of B. Matrix B is this one, then multiply with matrix A, minus 1, 3, 2 and 0. So first row will multiply with first column. You need to write here 1 with minus 1, plus sign 2 with 2. Then first row and second column. Still we are in the first row, so we have to write here 1 into 3 plus 2 into 0. Now we are multiplying second row, so we need to shift on this in the second row, minus 3 with first column, minus 1 plus minus 5 with 2. You can see what I am doing, minus 3 with minus 1 and minus 5 with 2. Similarly again 3 with 3, minus 3 with 3 plus minus 5 with 0. You can check here, the rows element will be same and the column elements will be this one, so that there will be no mistake. So minus 1 plus 4, 3 plus 0, minus minus plus 3, minus 5 times 2 is 10, negative 9 minus 0. So we will get 3, 3, minus 7 and minus 9, which is not equals to AB. So AB is not equals to BA. So first one we can say not possible. Generally, you know, the multiplication is not commutative, so AB is not equals to BA. So this one is not verified. In some particular cases, AB is equals to BA, but generally it will not be commutative. Now second part, we need to find A, B, C. So this one, for this one you need to find, first multiply B with C. So let's find BC first. BC will be equals to, this row will multiply with this column, so 1 into 2 plus 2 into 1. Similarly, first row will multiply with second column, so 1 into 1 plus 2 into 3. first row will multiply with first column, so minus 3 and minus 5, minus 3 and minus 5. Write the elements of column from above, 2 and 1, 1 and 3. So what we will get, 2 plus 2, minus 6 minus 5, 1 plus 6, minus 3 minus 15. So BC is equals to 4, 7, minus 11, minus 18. This is BC. So what will be A into BC? So now this A, this row will multiply with this column. So minus 1 will multiply with 4, plus 3 will multiply with minus 11. The same row will multiply with second column. So minus 1 into 7, plus 3 into minus 18. Similarly, second row of A will multiply with first column again, this one. So 2 and 0, 2 and 0, right here, and 4, just copy from above, minus 11, 7 plus minus 18. So finally you will get negative 4 and minus 33 will be minus 37, minus 7 and minus 54 will be minus 61, and 4 times 2 8 plus 0 will be 8, 7 times 2 14, 14 plus 0 will be 14. So this is the answer of A into BC. Now say this is equation 1. Now let's find AB into C of second part. Right hand side is AB into C. So to find this one, we are solving this second part. A will multiply with B. First find AB. This row will multiply with this column. So minus 1 into 1 plus 3 into minus 3. Same row will multiply with second column, minus 1 into 2 plus 3 into minus 5. Similarly, second row will multiply with first column and second column. So 2 into 0, 2 into 0, 1 plus minus 3 and 2 plus minus 5. So we will get minus 1 and minus 9. So it will be minus 10, minus 2 and minus 15, minus 17. 2 plus 0 will be 2, and 2 times 2 is 4, plus 0 will be 4. Instead of writing here, you can write here minus 10, minus 17, 2 and 4. Here we can find AB into C. So what will be AB into C? So first write AB, minus 10, minus 17, 2 and 4, and then multiply this one with C. So what is C? 2, 1, 1, 3. Now multiply this row with this column. So minus 10 and 2, minus 17 and 1. Similarly, the same row with this column, minus 10 into 1 plus minus 17 into 3. Similarly, this row will multiply with 2 into 2 plus 4 into 1 and 2 into 1 plus 4 into 3. So what we will get? Minus 20 and minus 17. 17 will be minus 37. Minus 10 and minus 51. Minus 51 and minus 10 will be minus 61. 2 times 2, 4. 4 plus 4 will be 8. 2 plus 12 will be 15. Which is same A into BC. So say this is 2. You can see here A into BC was minus 37, minus 61, 8 and 14. And here we have 2 times 2, 4. 4 plus 3. So finally we will get minus 10 into 2 is minus 20 and minus 17 will be minus 37. Minus 10 and minus 51 will be minus 61. 2 times 2, 4. 4 times 1 is 4. 4 plus 4 is 8. 2 times 2 plus 4 times 3, 12. 12 plus 2, 12, 13, 14. So this one is same as we found A into BC. Say this is 2. You can see here minus 37, minus 61, 8 and 14. All elements are same. So we can say this one is possible. 1 is equals to 2. So verified. This one is possible. You know, associative law with multiplication is possible for matrices. Next is part 3. First we need to find B plus C and then we need to multiply with A. So what will be B plus C? B plus C will be 1 plus 2. Corresponding elements you need to add. 2 plus 1 will be 3. Minus 3 plus 1 will be minus 2. Minus 5 plus 3 will be minus 2. Now we need to multiply A with B plus C. So A times B plus C is equals to, what is A? Minus 1, 3, 2 and 0. Better you write A and then B plus C. You have to write like this. First element first and then second element. Now you need to multiply minus 1 with 3 plus 3 into minus 2. Why this row is multiplying with this column? So minus 1 with 3 and 3 with minus 2. Similarly this row will multiply with second column. Minus 1 into 3 plus 3 into minus 2. Now second row 2 will multiply with 3 plus 0 with minus 2 and 2 with 3 plus 0 with minus 2. Finally we will get minus 3 minus 6, minus 3 minus 6, 6 plus 0, 6 plus 0. So we will have minus 9, 6 and 6. Say this is 1. Now we need to find AB and AC, then we need to add both. So how to find AB? AB, A multiplying with B, minus 1 with 1 plus 3 with minus 3. Similarly first row with second column, minus 1 with 2 plus 3 with minus 5. Second row 2, 0, 2 and 0, 2 and 0. Write like this, and column elements just copy 2 and minus 5. So this is AB, which is minus 1 minus 9, minus 2 minus 15 and 2 plus 0, 4 plus 0. So we will get AB as minus 10, minus 17, 2 and 4. This is our AB. Now let's find AC. A times C. So this row will multiply with this column. So minus 1 into 2 plus 3 into 1. Now the same row will multiply with second column. So minus 1 into 1 plus 3 into 3. Now second row will multiply with first column. So 2 into 0, 2 and 0. Right here 2 plus 1, 1 plus 3. So what we will get, this will be minus 2 plus 3, minus 1 plus 9, 4 plus 0 and 2 plus 0. So 1, 8, 4 and 2. This is our AC. But we need AB plus AC. AB plus AC. So this is AB and this is AC. Just add minus 10 plus 1 will be minus 9, minus 17 and plus 8, minus 9, and 2 plus 4 is 6 and 2 plus 4 is again 6, which is same as 1. You can see 1 here, minus 9, 6 and 6. So this relation also possible. Distributive law, AB into AC. So 1 equals to 2. So verified. Now let's do part 4. Part 4 is, first we will find B minus C. This one. So first find B minus C. B minus C is 1, minus 2 will be minus 1, 2 minus 1 will be 1, minus 3 minus 1 will be minus 4, minus 5 and minus 3 will be minus 8. This is B minus C. Now A into B minus C. A times B minus C. So what is A? First write A. Minus 1, 3, 2 and 0. And then write B minus C, multiply both. So this row will multiply with this column and same row will multiply with this column. So what we will get, minus 1 into minus 1 plus 3 into negative 4, minus 1 into 1 plus 3 into minus 8. Now second row, 2 into 0, 2 and 0. Just write like this, and column elements just copy from above. Now we will have minus minus plus 1, minus 12, minus 1, plus minus minus 24, minus 2 plus 0, 2 plus 0. So we got minus 11, minus 25, minus 2 and plus 2. This is the answer of A into B minus C, say equation 1. Now we need to find AB and AC, then we need to subtract. Already we found in part 3 AB and AC. So just I'm going to do here itself. What was AB? AB is minus 10, minus 17, minus 10, minus 17 and 2, 4. This is the value of AB we found already. Now what is AC? AC is 1842 minus AC is 1842. 4 2. Now just subtract this one. Minus 10 and minus 1 will be minus 11. Minus 17 and minus 8 will be minus 25. 2 minus 4 will be minus 2. 4 minus 2 will be 2. So this is same. 1 equals to 2. So this also verified. So question number 6, for the matrices A, B and C all are ordered 2 by 2. So multiplication is possible. A, B, A, C, B, C, C, A all are possible. So we need to verify that A, B whole transpose is equals to B transpose into A transpose. This is very important question. So let's see how to verify that. Solution for part 1. Take left hand side. Left hand side is AB whole transpose. So first we need to find AB. So what will be AB? This row will multiply with this column. So minus 1 into 1 plus 3 into minus 3. Similarly, first row will multiply with second column also. Minus 1 into 2 plus 3 into negative 5. Similarly, 2 0 will multiply with column, first column and second column, second row. So second row is 2 0, 2 and 0. Row elements I wrote, column elements you can copy from above. So AB is equals to minus 1 minus 9, minus 2 minus 15, 2 plus 0, 4 plus 0. So which is minus 10, minus 17, 2 and 4. This is AB. So what will be its transpose? AB transpose. You need to interchange this row into column. Minus 10, minus 17 and this row also in column 2, 4. So this is AB transpose. Say this is 1. Now we need to multiply B transpose into A transpose. So right hand side we need to find B transpose into A transpose. So what it will be? First, what is B? B is this one. What will be B transpose? B transpose will be equals to 1, 2, minus 3 and minus 5. Interchanging rows into columns. Similarly, what will be A transpose? A transpose will be equals to minus 1 and 3 and 2, 0. Now we need to multiply these two, B transpose into A transpose. So this multiply with this. 1 into minus 1 plus minus 3 into 3. Similarly, first row will multiply with second column. So 1 into with 2 plus minus 3 into 0. Again, second row 2 and minus 5, 2 and minus 5, 2 and minus 5. Same elements 0, 2, 3 and minus 1 and plus sign here. So we will get minus 1 and minus 9 will be minus 10. 2 times 2 is 2 plus 0 will be 2. Minus 2 and minus 15 is minus 17. 2 times 2 4 plus 0 will be 4. You can see this is same as 1. So we have verified this one. 1 is equals to 2. We can say AB whole transpose is equals to B transpose into A transpose. So verified. Now let's find second part. Let's verify part 2. So first we need to find BC. So what will be BC? This row will multiply with this column. 1 into minus 2 plus 2 into 3. Similarly 1 into 6 plus 2 into minus 9. The same row will multiply with this column also. Next row minus 3 and minus 5, minus 3 and minus 5. Column elements will be same, so you can just copy like that. So what we will get, minus 2 plus 6 is 4, 6 minus 18 minus 12, 6 minus 15, so here comes minus 9. So minus 18 and plus 9 times 5 is 45. So here we have 27. This is BC. So what will be BC transpose? Will be equals to 4 minus 12 minus 9 and 27. Just interchanging rows into columns. Now we need to find C transpose and B transpose. C transpose multiply with B transpose. What is C transpose? Minus 2 and 6, 3 and minus 9. And what is B transpose? B transpose is 1, 2, minus 3 and minus 5. Now just multiply this row with this column. Minus 2 into 1 plus 3 into 2. Similarly first row with second column with minus 3 plus 3 into minus 5. Second row with first column, 6 into 1 plus minus 9 into 2 and 6 into minus 3 plus 6 into minus 9. This was second row with second column. Now we can have minus 2 and plus 6 will be 4. 3 times 2 is 6, minus 15 will be minus 9. 6 minus 18 is minus 12 with 2, and 6 with minus 3, minus 9 with minus 5. So minus 18 and plus 45 will be 27, which is same. You can see this is 1 and this one is 2. So 1 equals to 2. Left hand side is equals to right hand side. This was left hand side, this was right hand side. So we have proved that BC whole transpose equals to C transpose into B transpose. Verified. So this was the end. That's it. Thank you very much. Have a nice day. See you in the next class, inshallah.